All right, so we're going to go over the stool tests. Now, there are two stool tests that I typically will run depending on the situation. We have the GI map test and then we have the gut zoomer test. And I'm going to go over both of them in the same video because they're very similar, but they use a little bit of a different technology, and so they excel at different things. Back to our model first, though, we're looking, remember, all of these tests are looking for sources of inflammation and stress. These are things that are causing the nervous system to feel threat for a variety of different reasons. So of course here we're looking at gut imbalances first and foremost, but it also tells us a little bit about infection because we can have infections in our gut, and it's telling us a little bit about toxins because the lipopolysaccharides you could consider to be an endotoxin, a toxin that is created by gut bacteria that circulates in the body. So it's not toxins like external toxins like chemicals, but it is a toxin that is generated from inside the body. So stool test gives us a lot of information. Now we always have to remember that the microbiome is a dynamic place. It changes. And these are snapshots in time. So we have to look for patterns, and we have to, I don't like going on killing sprees if we don't have to. I much prefer to support the ecosystem, support the good guys, so to speak, or the beneficial allies that we have in our gut, so that they can do their job better. But in some cases, when pathogens are really high, we can use some antimicrobials, we can use some antifungals to bring all that back in check. Now, we also have an organic acid test, which is going to be in a different video, that also gives us a little bit of a snapshot into the gut. I'm going to go over that separately. But right here, let's look at the GI map test first. This is a really standard test that a lot of people do. It's been around forever. It is a DNA test. Both of these tests are DNA, but they used a little bit of a different technology in that the gut zoomer is a bit more specific. It goes a little bit deeper, and that has its pros and its cons. The GI map test is a little bit more broad. But it does tell us about pathogens. So again, it's DNA. So it's looking for DNA fragments of all of this stuff coming out in the stool. So you can see this person has a little bit of E. coli, pardon me, which can cause stress and inflammation, but it could also just be transient coming through. So we always have to correlate stool tests with actual symptoms. If this person doesn't have a lot of diarrhea, doesn't have a lot of tummy aches, doesn't have a lot of pain, we may or may not do something about this. If they're constipated, this means we really need to get the pipes flowing so that the body can get rid of this pathogen, and then we may bring in some antimicrobials to knock it back. Depends on the person. But another thing I want to show you here is this here under DL means under detectable limits. So this means that it did not show up in the stool. Because we're talking about very, very microscopic components, microbes, they're using exponents. So under 1 to the exponent 3 is considered tolerable, it's considered normal, it's probably just transient and body is going to flush it. And then when it's a little bit higher, so you can see, then it's flagged as a problem. So you can see we're still in the same standard deviation. We're still at the exponent 3. We're not up into the exponents, 2. We're not up into the 3s, 4s, and 5s. So it's very, very mild elevation. So we're looking here for parasites, viruses, bacterias, that can cause a lot of toxic stress in the body, those endotoxins I was talking about. Parasites are notoriously hard to pick up on a stool test. They hide they hide in the mucosa. They sometimes will go up into the gallbladder, settle in the liver. They can be all kinds of places. So when it doesn't come out in the stool, it doesn't necessarily mean that they're not there. But if it comes out, chances are it's a pretty significant problem. But again, we have to correlate with symptoms, because it could be that the body has just passed these out and is no longer a problem. This is where we get into one of the main differences between the GI map test and the Gut-Zoomer test is this one picks up H. pylori a lot more. This one does have an H. pylori marker on it, but it doesn't pick up pathogens quite as strongly, and it doesn't pick up H. pylori quite as strongly. I like that because H. pylori and these pathogens are sometimes transient, and there's sometimes just need to just kind of run their course, especially if they're at very low levels. And when they show up on the GI map test, a lot of doctors freak out and go on a killing spree, which I don't think is necessary, especially in children. H. pylori is it's a big area of controversy. So you can see in this person, it's under detectable limits, and so the virulence factors are NA, not applicable, because unless H. pylori shows up as flagged, they don't even look for virulence factors. Virulence factors are factors that make the H. pylori more aggressive and more of a problem. I very, very rarely see these elevated in children. There is some evidence to show that H. pylori at low levels is totally normal and possibly even protective. It's a bacteria that lives in the stomach. When it's very, very high, the problem is that H. pylori has the ability to create an environment around itself that is low acidic. Now, the stomach needs to be a very highly acidic place. That's part of the strength of the stomach, is that the acid is high there, and so whatever comes in gets disinfected, and that is a very important protective measure for everything that's downstream. Things like salmonella and E. coli and all these things, when your stomach acid is low, you are prone to those infections, staph, strep, all of that stuff that comes in. The other important thing is that we need sufficient stomach acid in order to trigger the digestive capacity down below. So to trigger the bile, to trigger the pancreas. So generally speaking, when stomach acid is low, things slow down. We don't digest very well. We can get constipated. We can get infections. We open up the doorway. And then the third important thing about H. pylori is that certain nutrients are prepared for digestion in the stomach, most notably iron, B12, and protein. So you are all familiar with why those are important, particularly protein, because protein needs to be pulled apart into amino acids, and that starts in the stomach. So when there's H. pylori, and if we also have corresponding low stomach acid, because the H. pylori has decreased the stomach acid to protect itself so it doesn't get killed, we can have a slowdown of protein digestion. And that means that we don't have the neurotransmitters and the amino acids and the iron and the B12 to create our neurotransmitters. So that can certainly affect how a kid feels. But like I say, low levels in children are not necessarily a problem. High levels in children can be a problem. More often than not, when it shows up in a kid, it's probably coming from the parents. So it's a very transmissible bacteria that we transmit through saliva, through kissing, through towels, through sharing cups and forks and things like that. So when it shows up in a kid, before we start to really go after it and hammer it, I suggest that parents consider whether they might have H. pylori. Because if we go after it in the kid, they're just going to get reinfected if the parents have it. So you can run this section on its own through diagnostic solutions, or you can go to your doctor. It is not very easy to deal with, so that's why we don't want to have to make a problem where there's not a problem. So we have to carefully consider whether it's worth the time and energy and expense to go after the H. pylori. So that's a little bit on H. pylori. Then we get into the normal bacteria flora. So these are helpful microbes. And you can see in this person, we have a pattern of insufficiency. So we're not going to necessarily supplement with these particular strains. I look at patterns here because remember, we have to think broad strokes when it comes to the ecosystem of the gut. And we have a pattern of insufficiency. Sometimes we have a pattern of overcrowding. There's just too much. And you can think of a really crowded classroom, right? It's just like, there's no space, no elbow room. We gotta make some space. And sometimes we have the opposite. This piece here I find very helpful. This is the zoomed out view. We have the Bacteroidetes and the Firmicutes, which are both those are our main phyla, or our main families of microbes. So most of about 95%, maybe 90% of our microbes can fit into one of these two families, and they should be the most dominant. We want Bacteroides to be a little bit more dominant than Firmicutes. And you can see again in this person, we have a pattern of insufficiency. Sometimes they are way off. And actually, this is an older report. Now the new reports actually have a bar graph, so you can actually see it visually, which is really nice. Then we get into the dysbiosis, the overgrowth of the bacteria that are opportunistic. So they're not necessarily bad. I think we do need to get rid of that language of the good bacteria, the bad bacteria. It's not that they're bad or they shouldn't be there. The pathogens, they shouldn't be there. But these bacteria, they should be there, but within reference range. And when they are elevated, it tells us that they have an opportunity, they're opportunistic, right? They have an opportunity to grow and cause problems. So that usually means that these beneficial flora are low. Now, it's nice in this person that we caught this early because they don't have the sufficient normal bacteria, helpful bacteria to hold these in check. If we let this go, these are going to rise. These opportunistic microbes will take hold. These are the ones that have been connected with autoimmune disease. Those of you who have celiac disease or any autoimmune disease starting to show up in your kids. One of the things we have learned from Dr. Fasano and his colleagues and various folks who have been looking at autoimmune disease is that the gut microbiome plays a huge role. So if we see things show up here that are very much out of range, then your child is at risk for developing autoimmune diseases. And there in the compendium, you can see which ones are associated with which diseases, or which conditions. And if they do have an autoimmune disease, then we know that this could be potentially driving it and driving that autoimmune cascade. Because once you develop an autoimmune disease, you are more likely to develop another one, and then another one, and then another one. So this becomes a leverage point to pull that cascade back. Then we have Candida yeast and other fungi in here. This test is not fantastic for showing yeast. The organic acid test, which we'll get to, shows it much more clearly. So I do often find that when we run this test, it doesn't show up, and then we run an organic acid test and it does show up. They're just two different ways of looking, two different windows of looking in at the same marker. So again, we always have to correlate when it doesn't show up, but your child has a lot of yeast symptoms. They're getting a lot of yeast infections, or they have hyperactivity, or they have brain fog, or they can't sleep. All of those can be correlated back to yeast. You have a whole lesson and handout on that. Even if it doesn't show up here, sometimes we might want to knock it back anyway. Then we have some more parasites and worms. And then we have the digestive capacity part, the intestinal health part. Is fat coming out in the stool? If it's coming out in the stool, it's not getting to the brain, it's not getting to the cells. So that's really important. We need to support fat digestion. Elastase is a very general marker for digestion in general, protein and carbohydrate digestion. We want that nice and robust in a child. We want that right here where it is. 750 is great for a kid. Even though the reference range is over 200, that would be pretty low in a child. Beta-glucuronidase is a marker reflective of liver health and detoxification. This is in a good range of, is there any blood? If you do see blood coming out in your child's stool, that is something you want to keep an eye on. Generally speaking, if I see a lot of blood coming out in the stool, I will refer you to a gastroenterologist to see what the heck is going on. And then we have some immune markers here. Secretory IgA is our first level of response. It is an immune modulator that sits in the mucus lining, all of our mucus linings. So not just the gut, but our nose and our lungs and anywhere there's an interface between the outside world and our body. We have lots of secretory IgA. This is particularly focused on gut secretory IgA because we're looking at a stool test. And we want that when it's very, very high. Often that means a food reaction or some kind of, it tells us there's a lot of inflammation in the gut. And when it is low, it tells us that there's insufficiency. The body's not producing enough IgA, and that leaves a child prone to illnesses and infections. Antigliadin IgA is the only marker to do with gluten on this test. The wheat zoomer is far superior at understanding whether there is a reaction to wheat and gluten. When this is high, though, it tells us, yeah, we don't need to run a wheat zoomer. We know that there is reaction to wheat. I mean, we can still run a wheat zoomer because, as you learned, it tells us lots more. But if you can only run one test and you find that this is high, then you could probably forego the wheat zoomer and just take out the wheat and the gluten. When it is low, however, it is a non-marker. It does not tell us anything. It does not tell us that gluten is okay. It just tells us the body is not reacting in this particular way to gluten. So I'll refer you over to the wheat zoomer so you can see all the different ways that wheat can be causing a problem and gluten can be causing a problem. This is only one of them. So when this is a non-marker, I do suggest the wheat zoomer. When this is low, it does not tell us really anything. When it is high, it does tell us that gluten needs to go. And then calprotectin is a very broad general inflammation marker. Doesn't tell us anything about what's causing the inflammation, but when it's very high, we know we've got some investigating to do. Sometimes it can be high if a lot of these opportunistic bacteria are present. It can be high if there is irritation and a lot of LPS producers in the gut. It can be high when there's an infection. So it's just a general marker for infection. So that's it for the GI map test. You can see how it gives us a snapshot of where our leverage points could be. Do we need to knock back some pathogens because they're causing irritation? Do we need to support the immune system in the gut? Do we need to bring down inflammation in the gut? Do we need to support the beneficial bacteria in the gut? It's not perfect, but it does give us some significant clues. Now, the gut zoomer is also a very fantastic tool. You don't need to do both of them, but for some of you, I will choose gut zoomer over GI map test, mostly because if we know that there is a lot of inflammation in the gut, I find this one tells us more information about what's going on, and we can track it better. I really like this overview as well. So I'm just going to pull out a couple of pieces here. I like this part here. So just in this one, when we're looking at diversity of the microbiome, which is really the one thing that everybody agrees on, is that when it comes to gut health, diversity is amazing. The more diverse the microbiome is, the healthier a person is. That seems to be persisting in the literature. So this one looks a little bit more at that diversity, whereas with the GI map test, this is really the diversity markers that we have here, just the Bacteroides and the Firmicutes. So here's the Firmicutes and the Bacteroides here, but then it looks at other really important phyla. I particularly like to know the Proteobacteria because we want this under 5%. So for this person, we know, oh my goodness, you have a lot of troublemakers, potential troublemakers, these opportunistic microbes. This one will look at, where is it? This one gets really granular about which ones are in here, but it doesn't really matter. I'm really like how this gives us a percentage because we're not going after specific microbes, but here we know, you know what? Those opportunistic microbes are taking hold, and this is going to be a source of inflammation. And then when you look here, this is gut diversity. So we want these, both of these to be in the green, both of these things. So here on this index, which is just two different ways of assessing diversity. This is telling us, yeah, you've got the right microbes in there. This is telling us those microbes are not in the right ratio and not in the right place. That's what that's telling us. This section confuses people because it's not flagging you or your child. What it's doing is it is flagging, but what it's doing is it's taking your gut microbiome, your child's microbiome, and it's comparing it with the microbiome of people who have these issues. Hormone issues, irritable bowel disease, neurological issues. And it's just comparing them and giving them a score. So you can see with this person, their microbiome is looking a little bit like irritable bowel disease, but not quite there. SIBO is flagged. This is small intestinal bacteria overgrowth, which really correlates with this, right? You've got the right microbes there, but they're migrating into the small intestine, and we don't want them there. We want them in the large intestine. So all of a sudden, even just on the first page, we know the microbes are not in the right place. We've got too many potential opportunistics. But other than that, we're looking at a good robust microbiome. Gut pathogens were not found, so I kind of like that because it's just simpler. Here's our calprotectin, which we had. So our markers of inflammation. This is one of the reasons why I like this test when we think that there's a lot of inflammation in the gut, because it's much more granular. The inflammation markers on the GI map test are really just the calprotectin, which we have here. But then we also have all of these other markers of inflammation, which can give us a much more clear sense. Because here you can see, for example, calprotectin is actually okay, but they have lots of other markers of inflammation suggesting that things are not okay. So that's kind of nice. The reason I don't do this one all the time is because it's more expensive. So we have to just gauge what information we want and make a call. This is another kind of nice thing about this test is that if we run it again, this is a retest. So this is the first one that we did. Here's the second one that we did, and they will catalog it like that so that we can compare. So that's nice. These are those markers of insufficiency and malabsorption. So that will correlate with the intestinal health markers. So you can see it's a little bit more robust. Giving us similar information, but a little bit more of it. Breaking it down, it keeps going on. This is all still digestive capacity. Here's our secretory IgA, our beta-glucuronidase, our blood, our anti-gliadin. So that's similar to what we have here. But we also get a pH, which is kind of nice because sometimes when the pH is off, that can tell us, I think there's an infection in there that's not showing up. So it gives us sort of more windows into the gut. And then from there on, it just gets really granular, and it just really shows you like these are the actual species that they look for. So it would be akin to all of these. And it catalogs them in terms of what they correlate to. So you can see it's pages and pages and pages and pages and pages and pages. So I will go into those and pull out the most important pieces. But this is kind of you don't need to know this information. What is kind of cool about this test is that it rates the potential associated risk with how robust the research is on that risk. So you can see like it gives, I think it's a 5-star, or maybe it's a 4 or 5-star scale. And it gives us a little bit of a rating as to how robust. Sometimes it's like, yeah, there's like 2 stars. It's like, the research is not super robust, but there is an association with a potential associated risk. And sometimes it's more robust. So that's kind of nice. Yeah, here are some 5 stars. So for those of you who really like research, this is a nice test for that. And I believe it, so these are the parasites. I don't think that, yeah, it does give, it also does give you a little bit of an explanation here. So again, those of you who really like to know the nitty gritty of what each thing is, this is kind of nice for that as well. I was trying to see whether it has the research, but I don't think it does. I think their associated companion booklet might have some of the research around this, which I can give to you on request. So yeah, so there you go. Gut Zoomer and GI map test are both really good snapshots of what's going on in the gut. They are snapshots in time. They always need to be correlated with what's actually happening and all of the other pieces of information that we're gathering, right? Because remember, there are 5 sources of stress and irritation that we're looking at. This is just one of them. It's a significant one, but we have to look at them all together. So all of these tests, they're like windows looking into a house. The more windows we have, the better a sense we can get of what's going on in there. So these are the stool tests that I like.